Hello, my name is Paul Meyers. I'm from Heritage Christian School. I am a mentor and a parent, a coach. This is the Advanced VEX IQ Programming Techniques session, and I'm going to be using VEX Code IQ blocks. What we're going to do here is I've got a field set up and a camera pointing towards it. It's just a little field. And I've got a robot. This is last year's robot from Team 6210D, I guess. And they built a robot for Squared Away that we've done some conversion work and made it into a somewhat capable rise above robot. It is 4 motors, right and left drive motor. It has a single lift motor with a 5-to-1 gear ratio on the side, and it's got a gripping claw that was used for Squared Away that has been converted in a way that it can grip a hold of the risers and rise above. So it can only lift up to the point where it can stack one riser on a second riser, so probably not a top performing robot design, but it'll be good enough for what we're trying to do today, showing some advanced programming techniques. So let me move this out of the way. I'm starting with a completely clean screen with nothing programmed into it right now, other than the fact that I've got some all the motors established: drive left, drive right, lift, grip, gyro, and a touch LED, and a controller programmed in as devices. So we can start with that, and obviously all the ports are selected correctly. From here, we're going to start with our first concept, and that is to create some lift states for our arm. Obviously any robot can be run as a remote control toy where you push the button and hold down and the motors run up, and you let go and the motor stops. And you push the button and it goes down and the motor stops when the operator pushes it. But to be a robot and not just a remote control toy, we want to put some intelligence into the robot, and we want to do that by way of having some states. So what we're going to create is a set of bit of code here to create some states to run, make the robot run the arms, the lift, and the gripper close to the right spots. So we'll start with we'll just put it in when started for now, and we're going to create a motion where we spin the grip. Let's start with the lift. I'm going to turn this down a little bit. So what we want to do to create this is we want to have a forever loop that's continuously making the motors go to the right spot. And so first we want to establish where those right spots are. So we're going to create, in the forever loop, we're going to have an if statement that says if the variable, and I've already created some variables before, we're going to say if the grip state is equal to 0. So we're defining that the grip state, let's use lift state. We're doing the lift stuff here. So if the lift state is equal to 0, that will be our close position, and we will set a variable called the lift position to be equal to 0. And then we'll go ahead and do the same thing. We'll duplicate this block and create it again, and say this time if lift state is equal to 1, we'll make the grip position be equal to some number we're not sure for sure. We'll just put 100 in for now, and then we want to set the velocity of the motor, and this is where the kind of advanced stuff comes in. We're going to say on, oops, did that wrong, lift position. On the lift motor, we want to make sure everything says lift here because we're dealing with lifts. We're going to set the velocity to a little mathematical equation, and we're going to say that it is equal to this variable called lift position minus the current lift position. So we're going to sense from the position of the lift motor, so lift position in degrees. So we're going to say that the lift position, or the velocity of lift motor, is equal to lift position minus the actual position. So if lift position is set up here to 100 and the current lift position of the motor is 0, then it's going to give a velocity of 100 minus 0, which is 100, so it's going to go spinning upwards, upward velocity. And as it gets closer, it'll slow down. If lift position is 100 and the motor's position is 90, 100 minus 90 is 10. That means the velocity is only 10, so it's slowing as it gets to the proper spot. If it overshoots, or if it's pushed out of position by some external force, it'll say the lift position is equal to 100, and the lift position for the motor, the sensing value is 110. Then the 100 minus 110 is minus 10. Velocity minus 10 is it's spinning down. And so that combination of the simple mathematical equation will make the lift motor always seek its position, this lift position. And since we've set a couple of states here, state 0 to be equal 0 and state 1 to be equal 100, then based on those states, the lift position, the lift motor itself will seek those accurate positions. These can be easily adjusted, and here in a second we'll do some testing to figure out what the right numbers are. We do need a way to test those, and so we're going to create some control structure here. We're going to say when the controller button, let's use the left button for this. Well, let's use right. I'm a right-handed driver, so right is probably better. So we're going to say when right up is pressed, then we want to go into the variables and change the variable to of the lift state, change it by 1. So in essence, every time we push that button, lift state is going to go from 0 to 1, or from 1 to 2, or from 3 to 4, or from 5 to 6, because we're changing it by 1. That's not entirely what we want to do, because right now we've only got 2 lift states defined. Maybe we'll have more here shortly. In fact, I'm sure we'll have more than 2, but we just have 2 for now. So we're going to put a limit on this and say that so immediately after this change by 1, we're going to go and check to see if it's too high. So if the lift state, which we just changed, is greater than 1, so if it's 2, then we're going to change the lift state back to its limit value. So we'll go back and say lift state is equal to 1. Okay, so as we change from 0 to 1, it'll say, is it greater than 1? No, so we're not going to change it. But if we change from 1 to 2, then if it's greater than 1, it'll change itself back to 1. So this will create the control we need for the up button. Let's duplicate those blocks and create a down button version. This time we're going to change it by -1. So subtract 1 from it if the lift state is now less than 0. So we're going to have to go back here with and I'll have a quick fix for that. I'm going to have to switch this out and say if lift state is less than 0. So if it was 0, if it's 1, it will move to 0. If it's 0, it's going to go to -1. At this point, it'll say, oh, it's too far down, and it'll go to 0. So now those 2 controller inputs will control the lift state. So now we've got this connected to the robot. We'll go ahead and hit download. Let's bring our video back into frame here and hit play. And now we're going to use our right buttons to, oops, I'm going to turn this on. So now if I hit the R up button, it moves up to that first state. You see how it's seeking to find the spot. If I push it off, it's going to fight itself back into position. It's bouncing a little bit, so we may have to put a little bit of a scaling factor into that proportional bit of code. If we hit down, it goes back down to the 0 position. Up, if we hit more than one up, because of that if then, it doesn't go beyond the positive or the negative, into negatives or beyond +1 and positive. So now we have 2 states that control the lift. Okay, so let's stop this. Let's deal with that bouncing a little bit. So what we can do is, instead of doing the velocity is equal to the position minus the degrees, now typically this gets you in the right ballpark, because the number of degrees is, when you're off by 100 degrees and get 100% velocity, you're not that far away. So you typically don't have to do a lot of scaling here. But in this case, we'll grab a multiplication block. We'll drop this into that multiplication block and drop that back into here. And this time we'll put in a 2. So we're scaling the difference by 2. So we're going to get twice as much velocity. It's likely that will be the wrong direction, because we were a little bit too far before, but we'll see here. Let's hit download and we'll hit play and we'll see. Yeah, so you see what's going on now is, now it's so fast. Obviously the bottom hits the frame and it doesn't overshoot, but it's going so fast it's overshooting badly. So this scaling is no good. It's too high of scaling. So let's bring this back out, run this, and let's make it 0.7 or something like that. And download that. Hit play. And now, let's see, it's a little more stable. Okay, so we need the motor to hold itself stable in between the movements, and so we need to add a block here that is set stopping to hold. Brake, coast just allows it to fall away. That's the default. Brake slows it down, but doesn't fight to stay in the same position, and hold actually fights in the same position. So if we tell it to go to a certain spot, it'll hold itself into that spot. So let's go ahead and download that to the robot, bring the screen back up into view, hit play. And now the stability looks pretty good. A little bit of it wavering, but that's the motor just trying to keep itself in position. And so you can see we've got our 2 lift states defined. Obviously in this game we probably need more than 2 lift states, so we're going to go ahead and add in some additional lift states and try to dial these lift states in. One of the problems with the 0 lift state being at 0 is that there's some inconsistency as to where the 0 is based on how the robot was set down. If you push the motors down very hard, it'll be a little different than if you just allow the thing to rest slowly. So we're going to create some initialization code that allows the robot to set to 0 position very consistently. So let's do those 2 things now. Firstly, let's go ahead and create an additional state. We'll just duplicate this block here, drop it in here. Let's move this up a little bit. And that gave us a second one of those, which we don't need. And so now we'll have lift state 2, and let's make it more like 400, and this is probably more like 200. Want to dial those things in. And down here we need to deal with the fact that we now have a lift state 2, so if we change it up, if it's greater than 2, we're going to set it equal to 2. So now we've added a second lift state, different position, and we'll use that to define where the other states are going to be. So let's go ahead and download that. show the screen, hit play, and now we have a higher position for the first state, and we have another state that's further up, it's at 4, and we have the 3 different states. Okay, and if I hit the button too high, it doesn't go. Now, one reason this is a better technique than just spinning to a specific position is that if I go and hit twice, you can see it fluidly goes through the position. If I hit twice and hit twice again, if I hit twice and then hit down again, it stops. So it doesn't have to complete its movement before you can give it a different movement, because it's continuously looking at the button pushes. And if you had a spin to position, it would spin to this second spot, stop, and then spin onto the third spot. If I want to go through it fluidly, I need to be able to interrupt the movement in the middle of the movement. And the best way to do that is to just have it continuously trying to go to wherever the target position is, be it the bottom one or the top one. We got some lag on my video. Okay. Moving on, we said that we want to initialize this, so let's create some additional code. We'll just move it over here and create some more space, and we'll create an event that says when started. We want to set some initialization stuff, so we're going to set the lift motor to spin down. So let's spin lift motor down, because we've got a hard stop at the bottom we're going to spin against. We don't want to hit it with its full strength of its motor, because we don't want to bend the plastic and overheat the motor trying to spin down. So we're going to start by changing the torque, the max torque on the motor, to something smaller, maybe 20, and then we'll spin down. We'll give it a little bit of time to allow it to spin down and hit the bottom and hit a hard stop. So we'll just go for a couple seconds, and then we'll set the 0 positions. We're going to set the position of the lift motor to 0 degrees. That will set our 0 spot where we know that it's going to consistent every time we turn the thing on. It's going to start by running this motor down until it hits the bottom. Flex all the plastic that the max torque of 20% can do, and it'll set that 0 position to there. We then want to stop the lift from going on, and we'll set the max torque back up to 100%, because we want the thing to have full power when it's doing its normal stuff. Because this is all going to happen before we want the list states to be in effect to control the thing. We need to have this happen, and then we have to launch this. So we're going to use a control, an events that is a broadcast, and so we're going to broadcast. I've already created some names in here. We're going to broadcast lift control, and then here when I receive lift control, I will put all that stuff down. So now, when the program starts, it's going to run the motors down. It's going to wait until it sets it to 0 position. It's going to reset the max torque, and that's going to launch this lift control. Lift control will then take over. We can go ahead and put the set stopping into this when started, just so that it's kind of in with all the other initialization stuff. Now let's take a look and see how that works. Bring this back up into frame, and I'm going to make this be in the wrong spot to start. Just hold it there and hit download and play. So first thing it does, stop that and try it again. Hit play, it runs down, goes to position, and then it sets that 0 spot. And now these positions, the 0 and the 1 states, should be much more accurate because it's at the 0 spot in the thing. You can stop the program by double tapping this if you want to. That just kills the program. That's a nice feature of VEX IQ. Okay, now that we've got all that established, we're going to start working on the grip. The nice thing about VEX code is that you can copy blocks pretty easily, so let's duplicate all these blocks here so we can do a similar thing with the grip. I don't want to wait out 2 waits during this while this is going on, so instead I'm going to kind of combine these things. Oops, that should have been left. And so we'll change these all to grip. Grip. Because we want all that same stuff to happen for the grip. Didn't do lift directly. Yeah. Okay. And then we're gonna go ahead and I'm just gonna sprinkle these in amongst this so that each of the steps happen to both the lift and the grip motor. We don't need the weight. That can go away. And now every one of those steps happens to both lift and grip. And then let's launch via the broadcast the lift control and the grip control. I already established that earlier. Now we'll duplicate this block over here and call it grip control and spin the grip up. And now we need to change out some lift states thing. We've got grip positions to lift position, grip positions to lift position, and make this into the grip. This into the grip, and the ones internally here that are all lift position value needs to go away, and we go grab a grip position value, and lift states will do the same for grip state. Okay, now I have modified all everything that was in there that was lift is now grip. All right, let me double check that. And then we also want some controls for that, so let's duplicate this block, bring it over here, make it be into the lift state will be grip state, and we gotta switch this out manually, and this will be grip state also. And instead of R up, we're going to use L up, use the left buttons instead, and we'll duplicate that. It's easier to do it that way, and then we'll go L down here, and let's see, we need to make this less than, so this has to come out less than 0. And this needs to be -1, and this needs to be 0. Okay, so now just gotta do some side-by-side quality control. L up, R up, lift state, grip state. Okay, the grip state's really only got 2 states, so it's gonna be a 1 or a 0. So we'll go ahead and make this a 1 or a 0, and we'll take out the 2 state over here, and then we're going to do some testing to make sure that it works. Okay, so let's go ahead and download it to the robot. It's up here. And play, and now we can see that our initialization worked for that. Let's check the opening and closing. So open, close. Obviously the values aren't nearly big enough for that to open all the way up, and hitting down is currently closing it, and hitting up is open. I think that up should be lifting and or closing the grip to be able to lift, so let's switch those buttons so that when it's up it when you push the up button, you're preparing to lift up. So we'll go down to here. Let's put this, stack this under here for organizational sake. And instead of L up, we'll go L down. And instead of L down, we'll go L up. And that'll switch the buttons. And now we saw that the opening wasn't nearly open enough. Let's go like 500, over and up further. And let's download that, trial it. Hit play. Initialization is done. Now when we push the 0, the down button, it opens up. We push this button, it closes up. Okay, that looks good. And it looks like it opens far enough up, as far as we need. And now let's start testing this thing on a game object. So if we approach this game object, right, and we push the close button to close it up, it grabs it up. Push this to lift it up. Push it again. Okay, it looks like it's struggling a little bit to lift up over the weight of it. So I might have to make an adjustment to the design of the robot. Maybe some rubber bands to help lift it up to deal with the weight. Okay, I'll take a break and make an adjustment there. But we can see that our states are looking good. This state is obviously not high enough. Actually, now we have to worry about where the lift states are going to be, because it doesn't make a, obviously this will be the pick it up state. This will be the kind of drive it around the field state. There's going to need to be another state up higher where it can stack on top of a riser, and then there'll be probably an additional state, maybe a state even higher that allows you to clear over the top of the riser to drive around. So we'll work on that next. Okay, short break later. We have a set of rubber bands on the lift, the diagonal top to bottom, that help offset some of the weight of this motor and the plastic out here. So now you can see that the robot will be able to lift up a little bit better. We'll go ahead and hit play on the program. So one thing I can see right off is the opening and closing of this isn't very fast. Some of that's due to the 5:1 gear ratio that's in the robot. From last year, it was a lot harder to pick up the cubes and hold them, so that had to be stronger. So this is a little bit slowed down, but we can also adjust that in the scaling a little bit. It can't only go to 100%; it can only go so fast. But we could at least on the grip scaling increase this to maybe 1.5 to help it get there quicker. Let's download that. And play. Okay, and now open and close it. So there's a little bit of bounce in the outside there, but that should be fine. And then we can see that our closing up here and our lifting can lift all the way up to the height we want. Obviously that's not high enough yet because we can't clear this. Stack it on top of it. So let's go ahead and make an adjustment for that. Next, is this a comfortable driving around position? Maybe we could be a little bit lower so it's not as far off the ground, so let's do that too. So we'll make adjustments to our states. Lift state up. Let's turn this off. Okay, the lift state. The one position, let's make this more like 100 degrees. The two position needs to be high enough to, I guess, set hold the riser above the riser. Maybe even to set it down onto it. So we'll put this at like 600. And then let's go ahead and add another one. So duplicate this, drop it in here. We accidentally get a second one of these. And we'll say that for state 3, it's at 700, just a little bit higher than that highest position. And down here we have to make an adjustment so that it allows it to go to state 3. I'm going to reorganize the blocks. And let's go ahead and download that and see how that works. And hit play. So we've got our lift state, that's our drive around, lift it off the ground. It might be a little bit too close to the ground, so we may adjust that again. Now we go all the way up to 600 for that's next state, which, well, it looks like I got a little lucky here. That looks like it's got to be about the size to put it on there. And then there's the 700, a little bit higher, that allows you to drive over the top of it. That'll allow us to position it. Okay? So those are our 4 lift states at this point, on the ground, just off the ground, high enough to place the riser. And let's see, test on that. See, like, seems like that's pretty good. You know, it might be a little bit lower. Let's see, I don't think you can see it in the camera. So the concern here would be, when our riser is picked up, if we release the riser and then drive backwards here, we might still catch it a little bit. So we're going to want to have that position a little bit lower. So let's make those adjustments again. Lift position 3 at 700 looks fine. Let's make this like 570, and we want this a little higher off the ground, maybe 150. Yeah, let's go 550 on this one. Let's see what we get. Back to the camera. I'm gonna play because I just downloaded it already. You can see it's still in its thing, but it didn't get all the way to the bottom, so we'll hit play again. Okay, initializing its starting position. Open this up, close it up, and we're going to lift this up. Okay, that looks pretty safe to drive around. See that we've got decent clearance on the ground. We'll be able to get over the goals. In our next position, higher up, we're in a position where, now let's go to the highest position first, all the way to the top. You hear the motor's screaming a little bit. It's actually right up against the hard stop. So that may be something we want to adjust. If we drive over the top of that, we'll go down one position, we'll release the thing, and then we can drive backwards away from it, and it should be fine. So that looks like all of our lift and grip states are properly set. Okay, now what we want to do is tackle the driving of the robot. Locomotion, we'll call it. Let's move this. Let's kind of organize this a little bit better. This is the when started, so I like to keep it up high and to the left to kind of keep some organization going. So let's create, first of all, some dead zones in our controller. A lot of the challenges sometimes I see is the robots end up creeping around, moving on you because the control stick never fully returns to the 0 value on controllers. Oftentimes old controllers, it can never get to 0. So the best way to do that is to just do some logic to make it so that it doesn't move until you're higher than a certain amount. So what we'll create here is, first of all, we already have some variables set in that is left speed and right speed, and so we're going to use those variables to set this speed. So let's create an event that is when started, and inside of that we'll create a forever loop, because when forever continuously evaluate the controller stick positions. Then we'll do an if else inside of that and say that if else, and we need to look at the controller values. So we're going to say we're going to use an or, because that will allow us to decide if the control values, which is in sensing controller a position. So we're going to say if the controller A, which is the left up and down stick, if it is greater than or less than a certain value. So we're going to start with greater than, and we'll put less than in here. We'll say if controller A position is greater than or less than, so we'll say greater than 20 or less than negative 20. That means that it's not, it could be either in the position of 30 or 50 or 100. So that's a large positive value, or it could be in position, minus 30, minus 50, minus 100, large negative value. If it's in either of those, then we're going to set that left drive speed to be equal to that position, controller A position. Okay, and then if it is not, so the else condition, when it's not in that, it means it's 1 or 10 or 19 or minus 19. It's not in one of those positions. Then we're going to set that value to 0. So that will mean that if the controller's in any position that's less than 20 or in between that negative 20 and 20, the dead band, that dead zone we call it, it'll give it a value of 0. Okay, we'll do that exact same thing again by duplicating the blocks, but this time we're going to use the other stick, which the right hand stick is D, forward and back stick on the right joystick. So we're going to use D, and it'll be drive right speed instead of drive left speed, and that will do the exact same thing. Now the stick will control those variables, but we need to have the motors respond to those variables. So we're going to create some code that allows the motors to be set to those variables. The reason we want to do it like this is because this is controller based control of those variables, but in autonomous programming you're going to want to control the left speed, the right speed, potentially by way of some autonomous code, not by way of the controllers. And so as you develop this program, you can develop a program that can be used both for autonomous and driver control, with slight modification to take the controller inputs out of this and download it on the brain for the autonomous skills. So instead of just setting the speeds inside of this block, this block is a block that we will just delete away to make conversion from a driver control program to a fully autonomous program. So let's go ahead and create the block that will, or the code that will allow this to drive the motors properly. So we'll do a when started, and then we'll spin the motors. So what we want to do is spin drive left and drive right forward. We're going to spin, that just means that they're spinning all the time, they're continuously running. But we're going to set the velocity to be equal to that variable. That means that the variable drive right speed and drive left speed will control the speed of the motors. They default and start at 0. So right now, as soon as the program starts, it's going to say drive left, spin forward at a velocity of 0, and drive right, spin forward at a velocity of also 0. We want this to be in a forever loop because we want to continuously be able to change the velocity to whatever the variable is. So if the controller input is changed and the variable becomes non-zero because of the input on the stick becomes outside the deadband and becomes non-zero, then it will set the drive left and or the drive right to the appropriate speeds, and then if it becomes 0, then this will set the velocity to 0. When spinning forward and velocity 0, it's the same as just stopping. So that will do that. Let's go and download the program to the robot. And we'll hit play. The robot's going to zero itself, and now we're going to see if the sticks are correct. Okay, so the right motor responds correctly. So if you can see the stick, it's moving a little bit, but nothing happens until it gets up to 20. So I got this whole dead area where nothing's happening, and it goes on up to 20. I can get full speed out of it. And then the right stick, looks like I had the motor improperly established in the first place. It also has a dead band, but it's going the wrong direction. It's going backwards as I push forward. So let's make that adjustment very quickly. That's within the motors. Drive right. I'm going to reverse it. Done. And then download. And hit play. Okay. Now I've got two sticks controlling the driving. I can drive right and left, forward and back, and I can see that it's not moving when I take my hands off, even if it's slightly outside of the 0 spot because of the dead band controlling that. Okay. Okay, let's go ahead and see if our robot can function. We'll put a riser out here, drive out here. Let's open the grip up, drive onto that riser, close the grip, lift it up, drive over to the goal. I'm gonna lift it down, push it in the goal a little bit here, make sure it bottoms out, and we'll open the grip up and drive away. Okay, we have a robot that can score some risers. In fact, let's go ahead and do a second test. I think there's some rotational difference between where the posts are, so that is a design challenge this year. I think it works better like that. Now pick this up, we'll lift this up. We're going to go all the way up to that highest position. We'll drive over here. Can you see the thing? So over here, we're going to go down one state. So we went down one state, from the highest state down to the next state. We'll open our grip up and we'll drive backwards, and we've stacked a riser. Okay, if we had a more capable robot that could go higher, we could go 3 high and do completed stacks. We're going to need some way to launch the autonomous, so let's use the touch LED we already have defined in here. So we're going to, let's try to keep this stuff kind of organized. So let's move down to the bottom here for the autonomous. So we're going to do an event when the touch LED is pressed. In fact, let's do released, because then you won't be still touching the robot as the robot takes off. So it'll be on the release of the touch LED. We need to first, just to be able to test this and to be able to work within this program, we need to be able to disable the left and right speeds that is overridden by the controller. So let's put in an if block right in here that says, goes around all that stuff and says if we'll call this auto control. We'll create a new variable. Actually, you know what? Let's make it a boolean. Auto. No. Let's call it autonomous. So if, so we don't need the equal here. If not autonomous, we'll be running that. So let's put a not in here. So if we're not running autonomous, therefore autonomous would be true. That means this would be false. So if we're not running autonomous, we'll run the controller. So the controller will do this. If autonomous is true, then no longer will this be affected. This forever loop will just say, nope, not true, not true, not doing any of this. So that gives us control. So when we push the button, we're going to first set the autonomous to be true. At the very start, we need to set autonomous to be false so that it doesn't want to run off on us here. Okay, when started autonomous is false. Okay. So when the touch LED is released, the autonomous will switch to true. That means no longer will the the forever loop here be evaluating the controller and changing the values on the controller. So that means that now we can set the drive speed. So we're going to start by a pretty simple thing, and we're going to set the drive speed right, drive speed left. We'll make it some reasonable 50. So the speed of the motors are going to be 50% of their maximum speed. We don't want to go up to 100% and risk the challenge of running 100% is that not every motor is good enough to spin at a full 100%. And so 100% on two different motors, one will be a little faster than the other potentially, and so you won't go very straight. So by keeping your spins in your autonomous to a smaller amount, that will limit the amount of mismatch you have between your speeds. We're going to do that and do it for a little bit of time. This time we're going to do it by way of a while loop. So we're going to say while, and we're going to sense a value from the motors. So we're going to go look at the motor's position, and we'll just use the left motor for ease of sake now. We'll just say while this left motor's position is less than a certain amount. So let's go like 500. And we can just leave this while loop empty. Actually, I find it maybe makes more sense to put the while loop and connect it like this and put the speeds inside of the while loop. So basically, while the position of the left drive motor is less than 500, we're going to set those to 50, and then when we want to stop that, we can set them both to 0. So let's set these both to 0. Right speed and left speed both to 0. Okay. So what this is going to do is it's going to, when we touch the LED, it's going to set autonomous to true, which disables the controller's input. That's not, it's only necessary for during development. Obviously during a programming skills run, you'll have deleted away this code, so this won't be overwriting those variables, but it's necessary for this. And then we'll, while the position of degrees is less than a certain number, it'll set the value, and then it'll stop right here. Okay. Let's go ahead and show off our other stuff here. At the end of that, we'll set the lift state to be equal to 2. So it's going to lift up at the end of that to show us it's done, and then we'll see how that works. So we'll download that to the robot. We'll push play to get it to initialize. And then we'll just put some robot here, and we'll push the touch LED and see how it works. Okay, so that seemed to do what we wanted it to. We push the LED, actually we want to release the LED, right? So let's run that again, test that. So it's when we release the LED. So I push it, nothing happens, release, and it goes. Okay, so that's a pretty straightforward bit of code. Allows us to do that. Let's go ahead and I notice that the grip is closed when we first start. So let's start right up here and set the grip. This is kind of our initialization spot here. So let's set the grip value, grip state, to be equal to 1. So it's open when it starts up. Now when we run our autonomous code, let's drive out a little bit, and instead of lift state lifting up, let's go ahead and do the grip state and close the grip. So 0 is the closed value. And then we need to wait a little bit of time for that to get closed. So let's one way we could do this is just set some time limit, say wait for a second for it to close, or we can actually do some sensing to make sure it does it. So we can create an event here that's control, do another while, and say while the value of the So the value of the grip motor, we have an option right here for while this is spinning. So we'll say while grip is spinning. Okay, so we're going to just wait this out with an empty while, and so since set grip to 0 starts the spinning, we probably need a little bit of time to let it get spinning, because if this says 0, it doesn't start spinning immediately. We just can wait for 1/10 of a second. That'll give it some time for the program to start the motor spinning, and then while it's spinning, we're not going to do anything, so it's an empty while statement. And then we can set the value of the lift state. So let's set lift state to be equal to that 1 position, so it's off the ground. Okay. Again, we can either wait for it to stop spinning, or maybe we should just wait for a small amount of time. We know as soon as it starts moving a little bit, we'll be fine. So let's just wait for a couple tenths of a second. And then we can start doing some more autonomous moves. So we can start like driving in another direction. So let's go ahead and add drive speed right. Because we're going to do a little bit of a turn here, let's go ahead and make this a positive value, and then we can wait a little bit of time. There's a half a second. And then we'll make the drive speed left that same value, so it drives forward, and then we can wait a little bit of time. So there's various ways to do this. Up here we waited for a certain amount of distance for the motors to cover. Down here we're just going to wait for a certain amount of time, and then we will set both the left speeds and the right speeds to 0 to stop the program. Okay, download that, test that. Okay, I'm going to play. Set this out here and put a riser in front of it, and we'll run the program. Okay, getting pretty close very quickly. So you can see how with some timed moves and some simple moves, we can do some things pretty quickly. Let's stop this and bring this back. So the next thing we want to do is deal with making this a little bit more friendly by using the gyro. To have the gyro be automatically used by the drive motors, we have to do some additional stuff here with the drive left and drive right. What we want to do is not only set the velocity of the drive left and drive right to this drive speed, which is kind of the overarching control of the motor, we want to also set it equal to heading. So we want to say what heading we want to move it on. So let's take these out of here. So instead of having drive left and drive right control the motor, we're going to have 2 new variables called drive speed and drive heading. These will now control the robot. Instead of left speed and right speed, it will be drive speed and drive heading. So the speed will be positive for going forward, negative for going back, and it'll be the heading will determine which heading to go onto. So what we have to do is a little bit of math here. We're going to say that the drive speed is equal to the drive left is going to be equal to drive speed plus the difference between the drive heading, which is our optimal direction that we want to go, minus the gyro's value. And so we'll go in here, find the value for the gyro rotation in degrees. Okay, so heading is actually a bad term here because there's actually two different things. The gyro in VEX code, there's heading, which is 0 for straight ahead, and positive 10, 20, 30 when you're turning right some, and then negative. There's no negative. It actually comes around for 359 degrees when you go to the left. And so that doesn't work good for math. What we want to use is rotation in degrees. With rotation in degrees, we get a 0 value straight ahead. If we go a little bit left, we get a negative value, negative 10, negative 20 as it turns a little left. And as we go right, we get a positive value. And so that allows for the math to work out for this. The heading. So let's do some quick addition here. If the drive speed is 50, then and the heading and the gyro match exactly, then the velocity of the left motor and the right motor. In fact, let's go ahead and finish this up. So the left motor. Let me look at my notes here. Yeah, okay. The right motor is going to need to be positive, so plus, and the left motor is going to need to be negative. That's just the nature of the way the gyro works out. And we need another operator of a minus. Okay, and so we're going to do drive speed minus drive heading, and subtract that from rotation degrees. Okay. So if the drive heading is 0 and the gyro is 0, then 0 minus 0 is 0, and the drive speed will be 50, and so it goes straight forward, right? If the gyro value gives us 10, because it's turned right a little bit, then our 0 heading minus 10 is going to get minus 10. The drive speed is going to be adjusted by that 10, that minus 10 to make it a little bit faster. So it will pick up the speed and drive to the right a little bit. And obviously that same 0 heading minus 10 rotation will give a different result, and that means that on the left motor it'll slow down a little bit, the right motor will speed up a little bit, and that'll keep it back on to course. So we want to test this and make sure I got my minuses and pluses right. If it's not correct, then obviously as it gets off of its heading, it will actually try to adjust further away and drive off into out of control circles. So we'll be able to tell whether it's correct right away. So let's pull this block off here and just do a simple set drive heading to 40 and set, oops, sorry, let's make that 0 straight ahead, and we'll set the drive speed to 50 is fine. And then we'll do a wait for a second and then set the drive speed back to 0. Okay. I'm setting drive speeds more often, so let's just put that as the default in the variable. Okay, so now when we touch the LED, our autonomous is going to be true, then drive heading it was already 0, so this is really not needed. But the drive speed goes to 50 for a second, and then it stops at 0. Let's go 2 seconds, a little bit longer. Okay, let's download that. Bring our camera back up into view. Okay, so now it's a little more important that the gyro, I started it somewhere consistent. I'm going to start against the wall here. Because that's our 0 heading. If we hit our button, oops, okay, that was the old code. So we obviously didn't get our new stuff downloaded. And download again. Okay, so that's doing the 2 seconds worth of driving and stopping. Let's run it again. But this time I'm going to try to knock it offline so we can see how it affects the gyro effects. So hit the button here. So you see how when I knocked it offline, it continuously fought itself back onto position. So it's working the way you want it to. In fact, you can see how right now, because that autonomous is running, and because the program says that the left wheel and the right wheel speeds are based on how far it is off of that gyro heading, it's continuously fighting itself to stay on heading. So, it looks like we got a fair amount of drift in the gyro here. Might need to improve that a little bit. Let's create a calibration routine to offset that drift. Okay, so right at the beginning of the robot, before we do any of the initialization, so when you calibrate a gyro, that you really want you to have hands off the robot, so you're not making any bumps on the gyro, so that it will not artificially think that is what is still. When the gyro doesn't know what's still, other than the fact that when you calibrate it, it needs to know what's still. So we need to initialize the gyro and keep it from drifting. So we're going to use our when started program up here. We want to have the gyro calibration happen before any of this movement. So we're going to calibrate gyro. Here's the block for it. Calibrate gyro at 4. We'll use 4 seconds to get a little more accurate. And then it'll move on to this extra stuff. So that'll be the extra little bit. It's nice to know when it's done. So let's play a sound. We'll use da-da. And at the end of the calibrate gyro. Okay. So let's download that. Okay. Now we're going to play it. You can see in the first 4 seconds there, we got the calibration. We're going to hit the button here, and we're going to watch and see how now it doesn't want to drift as much. See how the gyro is still fighting to stay on course. Well, it's not drifting as badly as it was before because we did that calibration, and we were very still with the robot when it was calibrating. Okay, let's go ahead and make some more code with this. We're gonna go ahead and just build on what we've got here. Actually, I noticed in one of the things is there's actually a controller disable, which I think could have worked for our autonomous true if up here. This controller disable block could have done that. I'm gonna put that in there just for fun. But it's controller disable, controller enable, so you could have just the same as what we did. In fact, I'm going to go ahead and put at the very bottom of my program a set autonomous to false. I'll take that out just so not confusing. So they have controller override of the controller again. And now I'm going to use some of the program I created earlier here. So instead of this waiting for 2 seconds, we'll go ahead and do this while, so that we've got a distance controlled here. So while the distance is here, and we'll do the drive speed is equal to, oops, okay, it 50 within inside of that, and then it stops at 0, just like we were doing later. Let's go ahead and set the grip state to be 1 and lift state to be 1, and then we will set our drive speed heading now. So instead of at the end of that little motion going forward, grabbing the riser, lifting up, waiting for that to get done, we're going to set our heading instead of that to minus 40 degrees. Something that drives off to the left. we can wait for a little bit of time for that to complete, and then we can set our drive speed again to 50. Now this 50 is now going to want to drive on that 40-degree heading, and so we'll do that, and again we'll just for brevity put in a certain amount of time for it to go to. So we'll go to a couple seconds, maybe 1.5 seconds, something like that, and then we'll set the drive speed to be equal to 0. So that's stop the robot. Hopefully that'll be in the corner, and then we can set our lift state. Again, this is all kind of just imagining what's going to happen, so after this is all programmed, we're going to trial and error it. We'll set the lift state to 0 to set it down. Give ourselves a little bit of time for that to happen. 1.5 seconds. We will also set our gripper state to 0, actually to 1 to open up, and then we can wait for a little bit of time for that to happen. 1 second, and then we can drive set our drive speed to a negative number. Let's go negative 50. Again, the whole time this is happening, the drive heading is still on that negative 40. So whatever angle we took into there, we'll make that 45 on a negative 45 in there, and then this will back up for a certain amount of distance or time. We could have done it with distance, we'll just do with time, and then we'll set the drive speed to 0, and we'll set autonomous to false. So I've got driver control back. So let's go ahead and download that. And put our riser out in front of our device. You notice I haven't unplugged the cable at all the whole time. I find it much better to not have to do that all the time. Eventually the robot will move around the field enough to where that's a problem, but for little short tests you can do this with keeping it plugged in the whole time. Okay, so the gyro initialized there. We're happy with everything lined up, and we'll hit the button, drive out. Okay. Made a mistake on the negative 40. It should have been positive 40 for the heading, and it looked like it didn't grab the riser either. So make a couple of adjustments. This has got to be 45, not negative 45. And the riser didn't even grab the riser, so let's give it a little bit more time before the lift state is okay. We need a little bit more time here to allow the gripper to start spinning. I think it jumped right over that, and so this grip state got set to 0. It waited for a tenth of a second and said it was spinning. It obviously hadn't started spinning yet, so that it just jumped over that and went on to the rest of this program. Let's give that a little bit more time too. Okay. One more trial here. Let's run the program. Okay. Select the download. Hit play. Okay, it was tripping a little bit at the beginning there, so let's go ahead and try it again here. Hit play. I want the robot to be super still during the gyro initialization, and then here we go for our test. And that's almost the score of a riser autonomously. Now that's all I'll do today, as I think about a time. Thank you so much for watching, and good luck this season with Rise Above.